Hello and welcome to Interactive Classes. Myself Subhajit Roy. You must be wondering why I am here. Actually, I will be taking the class 10 from now, and Akash Kaur, who was taking the class 10, will now take class 11 and 12. So let's get started and hopeful that this journey will be nice. So let's start it with our chapter Coordinate Geometry. So welcome to the chapter Coordinate Geometry. We will be starting it today. So before starting, let me give some basic idea or concept regarding the chapter. So in the previous class we have already learned that the Cartesian plane, this is x-axis, this is y-axis, this is x dash, this is y dash. We have learned this in the previous classes, and the midpoint is known as the origin. And let me give some more ideas about this. The x-axis is also known as abscissa, and the y-axis is known as ordinate. And this is the origin, we already know. And what is the importance of this Cartesian plane, or why this chapter coordinate geometry? If we talk of any point or any location in the 2D plane, suppose this point, then we will have some distance in x and obviously some distance in y. Now suppose this one is x and this one is y. So the position of the object will be, or the coordinate of the object will be x comma y. That means the displacement in x and the displacement in y. Suppose here is any object, then the displacement in x be p and the displacement done in y-axis be q. So the coordinate will be p comma q. First the distance in x and then the distance in y. And here we can write the coordinate of the points. This is the basic which we have already learned in class 9. Now what's new in this chapter? Actually in this chapter we will learn three formulas which we will apply and find. Suppose, let me give one example. Suppose two houses are like this. The first house is here, the position or the coordinate is given, and this house is here and the coordinate is given. So it is told that find the distance between, or the displacement between the two houses. So this case we will use this coordinate geometry and many more which we will learn in the upcoming days. Now let me move to the chapter. Hope my point is clear. Now see, the first is our distance formula, and we will learn this distance formula today. Now the distance formula, suppose indicated by S, is the root over of x2 minus x1 whole square plus y2 minus y1 whole square. Now you may be wondering that what is x1, x2 like this. Yes, I will tell, but let me demonstrate first. Suppose a line is there like this. This is a line, and this is x1, y1, the initial coordinate, and this is x2 comma y2, which is my final quadrant, which is my final coordinate. Now this thing, now just see one thing, how to understand that which is initial and which is final. It doesn't matter. You can take any point, initial or final, because the distance will be same. From this point to this point, distance same, and from this point to distance, the distance is same. So it doesn't matter that which point you take as the initial and which point you take as the final. Now just see the formula now. The distance between this point to this point is given by root over of x2 minus x1 the whole square plus y2 minus y1 whole square. Now let me derive this formula with easy concepts. Now it's time for the derivation of the formula, the distance formula. Now what we can see here is that the coordinates are there, that is x coordinate and y coordinate, and we can see the line of which we have to find the distance. So let this be the initial point and this be the final point. I already told that it doesn't matter, you can take anyone as the initial and anyone as the final one. So let me take x1 y1 and this is x2 y2. Okay, now just we have to do some construction. What are the construction? I have to draw a perpendicular from this point, from the final point on the x-axis, and similarly from the initial point to x-axis. We have to draw this. Now let me make the quadrant of x1 y1. Now okay, acha. Now see, we have to draw another perpendicular like this. My drawing is quite rough, but you can understand. From initial point on this line. Now our construction is ready. Now what we have to do? We have to find this distance, this measurement. Now from the previous concept, I can say that this distance, this is the origin, 0, 0 origin, and this distance is x2. Why? Because see, here the coordinate is x2 y2. That means the distance covered in x is x2. I already told in the previous part, easy concept, x2, this is x2, and similarly here it is x1. So this much is x1, this much x1, and the total is x2, just because seeing the coordinate, sorry. Now then this thing will be what? x2 minus x1, because the total is x2 and this one is x1. Done. Now see this portion in the y-axis. Similarly, this total is what? y2. This total is what? y2, and this much is what? This much, if we compare, we see that this much is only y1. Then the remaining one is what? y2 minus y1. Now see one thing, this is a rectangle because all the four angles are 90 degrees. So if this point, let me name it AB, CD, E. Let me name it, okay. If AB equals to x2 minus x1, then CD will be also x2 minus x1, because the property of triangle, opposite sides are equal, x2 minus x1. And this is what? y2 minus y1, this side. Now let me erase and write only this part. This part is what? y2 minus y1, this part. Now if you see, this is a right angle triangle. Obviously if this is 90 degree, then this is also 90 degree. So triangle CED is a right angle triangle where this side is y2 minus y1 and this side is x2 minus x1. Now we can use our Pythagoras Theorem and we can state that CE, which is the magnitude of this line or the distance of this line, is equals to the square of this equals to DE square plus CD square. This is the Pythagoras theorem that hypotenuse square equals to base square plus perpendicular square. Okay, now see, then CE will be root over of DE square plus CD square. Now D is what? y2 minus y1 whole square plus CD is what? x2 minus x1, then x2 minus x1 whole square. Now see, the formula is derived. This is only the distance formula. You can also write in exchange form, no problem, same matters. So hope the derivation is clear to you. The derivation of distance formula just by using simple concept and the Pythagoras theorem.